we were asked to make a video about Newton's second law of motion by observing motion in real life, capturing it, and showing how Newton's second law applies to it. So basically, a consequence of Newton's second law of motion is that an object moving without any force acting on it continues with constant velocity. And I chose the system to show that by recording a stress ball moving from left to right by being pushed initially. Simple as that. I then uploaded the video to Tracker and set the ball center as the center of my coordinate plane as the origin, and I inserted the calibration stick, measured the ball diameter to be 0.07 meters, 7 centimeters. Then I got its point mass and chose to record the video from frame 27 to frame 47. That is where one of the intervals where the ball is acting without any force acting on it, and then I inserted the center of mass within each frame, so it ended up looking like this. And then the results came out of position versus time. Time was measured, of course, by checking the frame per second, and we have 20 frames. Multiply that by the frames per second, you get the time. The graph was a negatively sloped straight line, which shows constant velocity with the ball, and the line shows constant velocity, of course, because velocity is change in position over time, and the line is negatively sloping and going downwards because the ball is moving in the negative x direction according to the coordinate plane that I set. We then open Python to get data. We first insert the ball mass. The mass of a standard stress ball is 0.77 kilograms SI units. Then we insert the initial ball position, which is 0 in the coordinate plane, and the initial ball velocity, which we calculated to be negative 0.6. We got the ball velocity by getting the second ball position minus the first ball position over the second time minus the first time. And then we plug in the equations according to Newton's second law to get first the final velocity of the ball, which is Vf equals Vi plus F net over m times delta t. And of course the position for the final ball position, Rf equals Ri plus V average times delta t. And when we run the model, it gives us a model of the ball moving from right to left, like what happened in the actual video, and a negatively sloping straight line like the one we got from Tracker. And we also get the time 0.702 seconds by dividing the frames per second of the camera by the number of frames we recorded between. Then we want to move all the data to an Excel spreadsheet to analyze them further. When we do so by uncommenting where it says to uncomment, like here and here, there are several spots. Commenting is just deleting that small sign on the left, and also here. And when you run it, it saves the file in an Excel sheet, which ends up looking like this. And it has all the data of time and position. Then you plot a position versus time graph. I made one for Python and another one for Tracker to compare and contrast between them. And then I put both together to take a closer look. So they overlap in pretty much every point, and they're almost perfectly aligned. But there are minor discrepancies, and I think Tracker is more realistic because Python is more robotic and it sees the ball moving in a perfect straight motion with constant velocity, while Tracker accounts for the fact that the carpet is not perfectly flat or perfectly straight, so the ball at some points moves faster or slower. In conclusion, the system follows Newton's second law of motion because in the 20 frames that where the ball is moving without any force acting on it, it moves with a constant velocity. Thank you.